This is section 3.3. What we are going to be talking about is function notation. Now, function notation is simply a different way to write y. So up to this point, you've been writing things like y equals 2x plus 7. Well, now it says we're going to denote y as f of x. So instead of writing a y, I can change that out to instead say f of x. And it's still, f of x still means y. It's just a different way to write y. Right, so this notation, as I already said, is read as f of x, f of x. So you're actually calling this function f in terms of x. It means the value of a function named f when you input x. So this, I hope this will drive home the point. It does not mean the product of f and x. So this is not f times x. This f of x is one whole symbol. You cannot separate this. F does not get separated from x. This is f of x, one whole symbol. You cannot break it apart. So if I tell you to solve for, let's say I say solve for f of 5. Okay, and I say solve the function when x is 5. So you input 5. And then you input a 5 anywhere you see an x. That's what function notation tells you. But when you get to your final answer, so you'd multiply 2 and 5, you get 10, and then add 7, you get 17. This would be your final answer. You do not divide up the 5. F of 5 equals 17 means when I input a 5, I get out a 17 in this function called f. Okay? So let's do some examples with that. So again, one last time. F of x means y. It's another way to write y. And you read it f of x, it does not mean that you are multiplying f and x. F of x is its own, think of it as its own symbol. All right, so here's our first official example. It says evaluate the function. This is our function f, when x is negative 4, and then when x is 2. So it's telling us to do two things. Here's part A, when x is negative 4, and then here's part B, evaluate the function when x is 2. All right, so for part A, when x is negative 4, what that means is everywhere I see an x, I'm going to input a negative 4. So f of, it's not going to be f of x anymore because x is now negative 4. It's going to be f of negative 4. So kind of a strange way to see this because up to this point you haven't seen this notation. You would just see a y and then you'd input negative 4 for x. So what we're going to be doing is anywhere we see an x, including the x right here, we're going to input a negative 4. So we have negative 1 minus 2 times negative 4 because x turns into a negative 4. So we go ahead and simplify this right-hand side, follow the order of operations. So we have multiplication. We want to do that before we add or subtract. 2 times negative 4 is negative 8. So this is minus negative 8. The double negative makes a positive, so this is negative 1 plus 8. And then negative 1 plus 8 is 7. So if I just carry this f of negative 4 down throughout my problem, I get f of negative 4 is 7. And the reason that function notation is useful is because we can, without going back through our work to see what we actually plugged in, we can look just at our answers and say, okay, I plugged in negative 4 to function f and I got out a 7. So when you input a negative 4 into this function, you get out a 7. That's what this notation tells me. Here's your input, there's your output. Negative 4 is the input, 7 is the output. All right, so part B. Part B says evaluate this function when x is 2. That's a separate problem, so find f of 2. Evaluate f of 2. So we're going to plug in a negative, we're going to plug in a 2 for x. So replace the x here with a 2. All right, so follow the order of operations again. F of 2 is negative 1 minus 2 times 2 is 4. So f of 2 is negative 1 minus 4 is negative 5. And that's it. F of 2 is negative 5. So again, I can see what I input. I input 2 into function f, and I got out a negative 5. All right, second example, evaluate the function when f of x is 10. Okay, this one is different. This is saying f of x is 10. On the last one, it was saying x is a number or x is a different number. So here, f of x is 10. It's telling me to replace the entire f of x. This entire f of x gets replaced with a 10 because it's equivalent to 10. So f of x is 10. Instead of writing f of x, I write a 10 in its place. Everything else stays the same, just the f of x goes away, gets replaced with that 10 because it says f of x equals 10, or 10 is f of x. Alright, I need to solve, so it says evaluate, so I need to find the value of x. So I'm going to add 1 to both sides. That cancels out that negative 1. I get 11 equals negative 2x. Divide both sides by negative 2. That cancels out the negative 2 with the multiplication. X is by itself, and I get 11 divided by negative 2 is negative 5.5, or negative 5.5. Alright, so how I'm going to write my answer, I'm just going to put my variable first, x equals negative 5.5. You could also write this in function notation. You could say, when I plug in negative 5.5 for x, I will get out a 10. So there's my x. So I plug that in for x. And what does f of x equal, or what does function f equal when I plug in a negative 5.5? Well, I know it's going to equal 10 because I plugged in 10 for f of x to find that value of x. So either one of these is sufficient. I'm going to have to double check on your assignment to see how the authors represented their answers, just so it makes grading a little bit faster, but either one of these would be correct. All right, number 3, let C of t be the number of customers in a restaurant t hours after 8 a.m. Okay, so this one's a little bit tricky. C of t, so function C is the number of customers. T, I'm going to use a different color for that. Here we go. T is the number of hours after 8 a.m. So we have two things going on here. We have C of t and we have t. So when I look at C of t, C of something, so just ignore this 2 for a second, that's C of something, C of t equals 8. Well, C of t is the number of customers, so C of t is 8. So it tells me there are 8 customers. That's the first part. C of something equals 8. C of something is the number of customers, and it equals 8, so there's 8 customers. Now look at the other part. This is C of t. Well, t got replaced with a 2. T is now a 2. So t is 2. And look back at your problem here. It says t hours after 8 a.m. So we're 2 hours after 8 a.m. So there are 8 customers 2 hours after 8 a.m. Well, what time is it? If it's 2 hours after 8 a.m., it must be 10 a.m. It's 2 hours after 8 a.m. So there are 8 customers at 10 a.m. And that comes from that 2. The 2 is the t, and t says the number of hours after 8 a.m. So that is my answer. That is the meaning of the statement C of 2 equals 8. There are 8 customers at 10 a.m. for this problem. Example number 4, very similar. It says let C of t be the number of customers. So again, C of t, just like the last problem, is exactly the same. It's the number of customers in a restaurant t hours after 8 a.m. So it's the same scenario. Explain the meaning of this statement. All right, so on this one, again, ignore the numbers for a little while. What this says, C of t is the number of customers. So this C of something is less than this C of something. So the number of customers here on the left there is less than this number of customers. So now let's take a look at the numbers. The numbers are 2 and 7. So what do those numbers represent? Well, again, those are in place of t. So I just erased where I had my t's, but these are C of t. So t is 2 over here and t is 7 over there. So on the left side of t is 2, and it's hours after 8 a.m. On the left side, we're 2 hours after 8 a.m. So this is at 10 a.m., 2 hours after 8 a.m. And this one is 7 hours after 8 a.m. So 7 hours later after 8 a.m., well, it takes 4 hours to get to noon. And then we have 3 more hours to get to 7 hours, so that's going to be at 3 p.m. So that's what it means. The number of customers at 10 a.m. is less than the number of customers at 3 p.m. Now I'm just going to type out that one real quick here. The number of customers at 10 a.m. is fewer than the number of customers at 3 p.m. And there is my explanation for that statement. All right, let's see how many more we have to go. Yep, we're almost done. 2 more to go. All right, find the value of x so that f of x is 4. Well, remember, f of x is a notation called function notation. Notation just means it represents something. So it's function notation. It represents y. So 4y. Okay, so that just came from the very first slide that we were working on, where I told you what function notation is. F of x is function notation for y. So when this says f of x is 4, what this implies is f of x is y, so it says y is 4. So find the value of x so that y is 4. So go on your graph here. Here's the y-axis, the vertical axis. Here's where y is 4. Go over to your graph. And there's the point on your graph where y is 4. And the question again says, find the value of x. Okay, so what's the value of x? Well, follow it right down here, and you get that it's 3. And that's all you have to do. So you would say f of 3 is 4. So what this says again is when x is 3, y is 4. That's it. Okay, so again, f of x equals 4 means y is 4. So go up to 4 on your y-axis, go over to your graph, and see what's the x-coordinate of that point. So you just go straight down, and I got 3. That's it. All right. The last question I have here is a fill in the blank. It says when you write the function y equals 2x plus 10 as f of x equals 2x plus 10, you are using what we've been using this whole section called function notation. Function notation. All right, so here is your assignment. I changed the directions for numbers 3 through 10. So on 3 through 10 in the textbook, it says you have to evaluate the functions when x, I think it says 0, 2, 4. It gives you like 3 possibilities. I'm just going to say only evaluate when x is negative 2. So I'm cutting down those problems a little bit for you. Let's go ahead and go through some of these homework problems. I told you I'd start going through half of the problems with you, so I'm going to hold up to that. I'm going to go through half of these with you. I'm going to do the odds. The odd problems are in the back of the textbook. The answers are at least. So what I'm going to require of you from this point forward is that you copy down the work that I'm doing. It's still part of your homework. I'm giving you free work because I want you to actually take the time to watch these. I don't know if everyone is actually putting in the time and effort to watch all of these videos. So I'm giving you free points just for watching me and copying them down. Now, of course, you could pause the video, try them on your own, and then compare to mine if you want to do that as well. That might help a little bit more. But for those of you that are struggling, it's really hard to do one-on-one help with all this online school. So hopefully this will help you a little bit more because you'll see questions that are very similar to the ones that you have to do. All right, so here we go. So I'm going to start with number 3. Let me get your textbook open here. Let's see, we were on page 125. 125. There we go. All right. So yeah, here there's 3 options. When x is negative 2, 0, and 5. Again, I'm just making you do it when x is negative 2. All right, so for number 3, we're going to find f of negative 2. And that's the only one I'm making you find. So when the function, evaluate the function when x is negative 2. So you plug in negative 2 for x. Plug in negative 2 for x. Maybe I should write the whole function down first here. So the original function is f of x equals negative, not negative 2, I didn't plug anything in yet. F of x is x plus 6. That's the original function from number 3 here. And it says evaluate the function when x is -2, so I input -2 for x, and now just combine the like terms on the right hand side, and I get f of -2 is 4, and that's the answer. Okay? Alright, moving on to the next odd problem, number 5. So again, you are responsible for all the even problems in this assignment. So number 5, f, oh, now they switch it up. It's no longer f. So one thing with function notation is that you don't have to call every function f. You can name them any letter or variable that you want. You could use, I mean, once you get into some college textbooks, the people that write these books want to make themselves look smarter. They start using things like alpha of x or beta of x. So they start going to Greek letters just to make themselves look smarter. But you can really use anything. So in your textbook here, they're just going to use some letters, so it's not going to get too crazy, but you could be lowercase, it could be capital, but you can switch it up. All right, so number 5 is h of x, so function h equals -2x plus 9. Again, I need to evaluate the function when x is -2, so I plug in -2 for x. I'm trying to find h of -2. Follow the order of operations, and I get +4 when I multiply -2 by itself. If I add 9, I get 13. So h of -2 is 13. Number 7. Number 7, p of x is -3 plus 4x. Again, evaluate when x is -2. P of -2 is -3 plus 4 times -2. P of -2 is -3 minus 8 when I multiply 4 and -2. So I get P of -2 is -11, and that's the answer. So when I input -2, I get out -11. Number 9 is the last one in this little section here. So it's v of x, so function v of x is 12 minus 2x minus 5. This one has some like terms in it. I'm going to simplify that right away. V of x is 12 minus 5 is 7. So I have 7 minus 2x. Now I'm going to evaluate that function for -2. Multiply the -2's, you get a +4. So v of -2 is 7 plus 4, which is 11. So v of -2 is 11. All right, next section here, we've got a word problem. This one is very similar to what was in your notes. Now, I said I was going to do all of the odds, but if it comes to something like this with multiple parts, I'm going to do one of the parts so that you're still able to do some of this. Number 12 is also extremely similar to what we're doing in number 11. It's just a different scenario. And actually, since I did so many of these, I'm gonna look through this real quick here. I'm gonna do actually part C with you because that's different than what we had in the notes. So let's do 11 part C. All right, so on 11 part C it says C of n equals 29. So now we've got a variable in here. And it says C of t is the number of customers. So again, C of anything, it doesn't matter what's right here. C of anything is the number of customers for that scenario. So C of, this is going to be a t, just ignore the n for a little bit. C of t is 29, and says C of t is the number of customers. So we have 29 customers. So that's what that tells me. So 29 customers. So 29 customers, and then I'm just going to jot that down. 29 customers. There are 29 customers. And then now let's take a look at the other part, the n. So again, n is replacing t. And what does t mean in this problem? T is the hours after 8 a.m. So instead of a t, there's an n. So how many hours after 8 a.m.? Well, this many. Whatever that means, n hours after 8 a.m. is so some amount of hours after 8 a.m. We don't know how many hours, but n hours after 8 a.m. So what that means is at some point after 8 a.m., there's going to be 29 customers. We don't know how many hours n is, but at some point after 8 a.m., there's going to be 29 customers. There's my answer. All right, so again, you are responsible for the other 3 parts of number 11, and you also need to do number 12. Those are going to be a little bit challenging, but please try your best to do those because that will really help you understand what function notation is getting at if you can understand these problems. All right, moving on, number 13. Number 13, it says find the value of x so that the function has the given value. So we did one of these like in the notes. We did this on this problem right here. Example 2 is very similar to these 13 through 18. So number 13. On 13 it says h of x is negative 7x. h of x is negative 7x. But now here it says h of x is going to be a 63. So if h of x is equivalent to 63, or 63 is h of x, I can put 63 in h of x's spot. And now solve. So divide both sides by negative 7. The negative 7s on the right are going to be canceling out here. And I get out a negative, because positive divided by negative is negative, negative 9. And I'm going to write this as x equals negative 9. So let me check your textbook's answers real quick. Again, I want to make sure we're writing these the same as the authors just to make grading a little bit easier for me. So give me a second to open up the teacher edition. All right, and sure enough, your authors are using they are using x equals 9 as the answer. So let's keep it as that x equals 9. If you put it back in function notation, you write it as h of negative 9 equals 63. But let's just write x equals negative 9. All right, moving on, number 15. On number 15, we have function m. It's m of x equals 4x plus 15. And on this one, they say that m of x is 7, so I'm going to replace m of x with a 7. And then I have to solve for x. So subtract 15 from both sides. And we end up with 4x by itself on the right. 7 minus 15 is negative 8. And then we get, if we divide both sides by 4, we get a negative 2 on the left-hand side. So I'm going to write x equals negative 2 as my answer. Going on to number 17. For number 17, this is function q. We have q of x equals 1/2 x minus 3. And on this one, it says q of x is negative 4. So replace q of x right here with a negative 4. And let's solve. So we add 3 to both sides of the equation. We get negative 4 plus 3 is negative 1. And then we're going to multiply both sides by 2. Because remember, this fraction is the same thing as dividing by 2 and multiplying by 1. So multiply by 2. That will cancel out the dividing by 2. 1x is the same as an x. And 2 times negative 1 is negative 2. So x is negative 2. All right, number 19 coming up. All right, number 19 here, it says find the value of x so that f of x is 7. So this one is the same as this example right here, example number 5. So on this one, not a lot of work to be shown here. What we've got here is find the value of x so that f of x is 7. Remember, f of x represents a y. So if y is 7, we're going to 1, 2, 3, 4, 5, 6, 7 right here. We go over to our graph. Right there at this point right here. That's when y is 7. What's the x coordinate at this point? That's what the question is asking us. It says find the value of x so that y is 7. So go down to your x-axis and you're at 5. So here, x is 5. If you want to write that in function notation, you could say f of 5 is 7. But again, your authors are not going to be using that notation, so you can just say x equals 5, and that would be good. All right, going on to number 21, the last one I'm going to go through. Number 21, this is a word problem. So on this one it says the function c of x, let me just write this down, c of x equals 17.5x minus 10 represents the cost of buying X tickets to an orchestra. So X tickets, X is the number of tickets. I highly recommend doing this yourself. So what I mean is defining your variable. So X is the number of tickets, and then it says C of X, the function C of X represents the cost. So C of X is defined as the cost. All right, and it's in dollars of buying X tickets to the orchestra with a $10 coupon, so that's why you're subtracting off the 10 there. All right, part A. Part A. How much does it cost to buy 5 tickets? Well, if X is the number of tickets, it makes sense to plug in 5 for X, since it's X tickets. So I'm going to evaluate the function C when X is 5. Follow the order of operations and you'll get this right. So C of 5 equals 17.5 times 5 is 87.5, and then we're going to subtract 10. 87.5, then we're going to subtract out the 10, so C of 5 is 77.5. All right, now this is a word problem, so we should write our answer out here in a sentence. So I'm going to say, again, this is our input, and there's our output, and X is the number of tickets, and C of X is the cost. So it will cost $77.50 to buy 5 tickets. All right, and then for the last part here, part B, it says, how many tickets can you buy with $130? Well, now C of X is the cost, so it makes sense to plug in 130 for C of X. So we're going to replace C of X with 130. This becomes 130 equals 17.5x minus 10. We have to solve that equation to get our answer. So add 10 to both sides. Turns into 140 equals 17.5x. Divide out the 17.5. Get x by itself. All right, so 140 divided by 17.5 is 8. So x is 8. And again, with the word problem, we should write this as a sentence. So I'm going to type this one out. So since x is the number of tickets, and we've got x is 8, so the number of tickets is 8, or 8 tickets costs $130. 8 tickets costs $130. And that is it. All right, so you are responsible for the rest of this assignment, and all you had to do was copy down the work for what I just did here. Again, the rest of the assignment is on pages 125 to 126, numbers 3 through 22. All right, let me know if you have questions. Thanks.